So we're on 3C.9 inverse trig functions. Okay, so the funny thing is I just taught this in dual credit and I thought I had taught it in U. I was like, wait, we've already did it. No, we haven't. That was dual credit trigonometry. We haven't did it yet. So yay, inverse trig functions. Here we go. So just like any other time when you are finding the inverse of any function, essentially what you're doing is your input and your output are switching places, correct? Yes, do you remember that? With the inverse function, you're switching your domain and your range, okay? So the same thing with trig functions. So instead of being given the angle, you're being given the trig ratio, and you have to find the angle because your domain and range are switching, okay? When you are seeing notation for trig inverses, there are two notations that you can see. One is called our standard inverse notation, so sine inverse. The other is arc. So you may see arc sine or sine inverse. These are the same thing. And the same thing goes for cosine and tangent as well. Okay. You may see it's arc sine of x. So the arc cosine of x, arc tan of x. They all mean inverse of trig, right? You're doing the inverse of it, regardless of which way you see it. Got it? All right. So I just want to make sure that we're all on the same page. So for example here, we have sine of pi over 6 equals 1/2, correct? If I wanted to write this as an inverse function, essentially what I'm saying is that my x and my y are switching roles, correct? Because my x and my y are switching roles. Try and write again. Oh my gosh. I'm gonna write. I'm gonna win. There we go. So currently this is my x and this is my y. When you're writing the inverse, your input and your output are switching. So when it asks for arc sine, I'm writing sine inverse of, and it becomes 1/2 equals pi over 6. Does that make sense? That's what the inverse does. Okay. If it wasn't here, this is essentially me. This is asking, when does sine of theta equal 1/2? If we're looking at the unit circle, that means we're asking, when does y equal 1/2? Does that make sense? Okay. So with sine and cosine, because they are sinusoidal functions, they are periodic, right? So the pattern is going to repeat over and over and over. Yes, I surely can. They're going to repeat over and over and over. When we learned about inverse functions in algebra, we talked about the fact that for inverse functions, no x values repeat and no y values repeat, right? We also talked about that when you're looking at it visually, it's going to pass the vertical line test and the horizontal line test. If I am a periodic function, am I passing both of those tests? I pass vertical, but am I going to pass the horizontal line test as a periodic function? No. So therefore, for sine and cosine, there are restrictions on your domain for the inverse. Just like with the quadratic function, do y'all remember the quadratic function? We have a restriction on our domain, right? The restriction on the domain is that its inverse is when x is greater than or equal to 0, correct? That's the restriction on the domain. For sine and cosine, there's also a restriction on the domain. So if you look right here, our restriction on our domain for sine is from negative pi over 2 to pi over 2. Because on this interval, are my x's and my y values repeating? No. On this interval, my x's and my y values do not repeat. So sine inverse of x. Your inverse means that your domain and range are switching. This is currently my sine. This is currently the graph of sine x, right? Looking at the graph of sine x, its range is from -1 to 1, and its domain is infinite, correct? But because I'm restricting it for my inverse, the domain of my inverse is what was my range on my original. And what was my range? -1 to 1. So my range is now -1 to 1. I meant my domain, I'm sorry. Yes, just to highlight it. Yes. So remember, for inverse, your domain and range switch. So currently for sine x, I should have written it out. Our domain is from negative infinity to positive infinity. However, because we want to find an inverse of it, we're restricting the domain, right? So our restricted domain is going to be from negative pi over 2 to positive pi over 2, correct? Our current range is from negative 1 to positive 1. When you're stating the inverse, it's going to switch. Your domain and your range do what? Switch. So for my inverse, its domain is what my range was, which is negative 1 to 1. My range is what my domain was, which is now negative pi over 2 to pi over 2. Okay? Exactly, inverse. Your x and your y switch places, correct? So if my x's and y values are switching places, so is my domain and my range. Okay? So what this applies to when we're thinking about the unit circle, that means on our unit circle for inverse sine, we're only using quadrants 1 and quadrant 4 because that's where the range is from negative pi over 2 to pi over 2. All right, we're going to do the same thing with cosine. Are we ready to do cosine? All right, so here's cosine. I don't know why I didn't put that goes on the other part. Ignore the top part. So now cosine, again, it is a sinusoidal function, which means it's periodic and it's repeating. So we have to define where it's no longer repeating before we can give it an inverse. So this is from here to here. Do we see that? Well, we're writing the parent function. So once we've established the parent function, that's it. Okay? So again, we're going to write what currently is. So the cosine domain is the same as the sine, right? It goes initially from negative infinity to positive infinity, but I have to restrict it. And what am I restricting it to? Where do we start? No, domain. 0 to pi. Okay? And our range on this interval is from negative 1 to 1. Okay? So now let's describe its inverse. So the inverse would be what then? The domain, no, on the inverse, remember, this is currently cosine. And what happens when you find the inverse? They flip it. So the range of cosine is now my domain. And then the domain is now my range. Okay, we're going to take a look at these functions on the calculator. I'm going to use Desmos to graph them just because it's going to give a bigger view. But don't think I'm disrespecting Sylvie, okay? Let me go here. Got my little Desmos. All right, so I'm going to type in sine inverse of x. So notice it literally is just this little piece. Y'all see that? That's it. That's the function. That is the sine inverse.
Why is it a little piece?
Because that's his restrictions. Are our restrictions not met? We said it only goes from negative 1 to 1. It would repeat it. Yeah. We had to restrict the original. So this is just the inverse. There's no asymptote. It is a function that starts and stops. Okay? Which is why we cannot use the entire unit circle. Does that make sense? We only can use quadrants 1 and quadrant 4. Okay? That's sine. Now we're going to do cosine. Cosine, shift 6, negative 1, of x. Cosine, like we said, it's also from -1 to 1. And its range is from 0 to pi. So notice I'm right above. And it'll show you that it's pi. That's the beauty that it'll actually tell you on decimals. Versus on Sylvie, she'll tell you 3.14, but blah, blah, blah. But on here, it'll tell you that it stops at pi. Okay?
How come like the domain we use isn't a full period? How do we just take that?
So a function doesn't have to go on for infinite. Functions can have starting and stopping.
It's like why?
Yeah, it doesn't have to be infinite. It's just that we deal with a lot of parent functions that either go on forever to the left and to the right or to one direction, right? But functions do not have to go on infinitely in one direction or both.
Yeah. So what would there be any difference? I guess yeah, it's 0 that's a pi.
Exactly. And there we go. That's it. And that's because we had to restrict the original function. Otherwise, it wouldn't have an inverse function because it failed the horizontal line test. It failed the horizontal line test, and then therefore it failed the vertical line test. All right. Tangent. I did not mean to put this here. Tangent was supposed to be on its own little page, so pretend that's a box. Tangent is a unique. So when you look at the tangent function initially, tangent has vertical asymptotes, correct? At every odd half, we have vertical asymptotes. Do y'all remember that? Yeah. Okay. So tangent by itself is already good to go, correct? So at tangent, your x's and y's switch. So you go from having vertical asymptotes to having horizontal asymptotes, right? And you go from going your range being infinite to your domain now being infinite. So I'm going to graph tangent so that you can see what I mean. So let's go look at tangent. So tan x looks like this. Agree? Here's tangent. All fun and lovely. And it has asymptotes, right? The asymptotes are at every negative, well, every half, every odd half mark. Okay? Now, when we do tan inverse, we're going to go from being vertical asymptotes to being horizontal asymptotes. Okay? Should -1 and arrow over x. Okay? So we went from having multiple vertical asymptotes to only having one pair of horizontal asymptote. Those horizontal asymptotes are now at pi over 2 and negative pi over 2. Because again, just like any other inverse function, your domain and your range have switched. Okay, so tangent, its previous domain was from negative infinity to positive infinity. However, it had restrictions, right? But x cannot equal, what was it? 2k plus 1 times a half. Huh? I think it's that. I think I'm running that right. I'm pretty sure that right. Where it repeats, right? Those are your asymptotes because it has asymptotes. And then your range was from negative infinity to positive infinity, right? Now these are switching. So they switch. For an inverse, your domain and your range are switching. So the inverse, its domain is now negative infinity to infinity. Your range is now restricted. Your range is now from negative pi over 2 to positive pi over 2. And that's because these are now your horizontal asymptote. Probably should have left you space to do that. In hindsight, it's okay. Yeah, probably should have left you space, but yes. Okay, so just in case you don't get what I'm saying, that's what it's telling you. At the bottom. I on the 10, on the side, on the box. There's a picture of it. We're gonna talk about it here in a second.
This is X not equal to what?
X can equal 2k plus 1. So like you're repeating. So therefore it guarantees that you're only on your halves.
Back to the slide for a second.
Yes. Oh, I can't do both. So if someone's writing this, I can't do. Are we done writing the domain and range? Okay.
Wait, so we write it here or down?
At the bottom. I said, yeah, I would write it at the bottom. You have more space at the bottom.
What right now?
Huh?
What do we
They-
write?
They just wrote it at the bottom underneath the graphic.
That's a K or 2X?
It's 2k plus 1. We already have the right. So you're remember we did tangent and 3b.8. You already have the domain and range written there. I just rewrote the from your notes.
Well, which side?
Wait, where 10 is for negative. 10.
Okay.
And then I finish every 4 hours of sleep. End up
All right. So that's what's most important here is when are we using them? Because of our domain restrictions, there are only certain areas that your calculator, any calculator is going to give you values from. Does that make sense? So for sine inverse, a calculator is only going to give you an answer between negative pi over 2 and pi over 2. If you're in degree mode, that means between negative 90 and positive 90, right? It's only going to give you values in that window because that's the only space that sine inverse is defined in quadrant 1 and in quadrant 4. Okay. Cosine inverse is from 0 to pi, correct? It's only from 0 to pi, which means that its values are going to only come from quadrant 1 and in quadrant 2. Tan inverse, it has restrictions because of the asymptotes. That's why it's not equal to. So we're not equal to because these are horizontal asymptotes. It got weird right there. Okay. But again, it's between negative 90 and positive 90. And if you need me to write between 0 and 180, I'm sorry, I will do that too as well. So when you're evaluating, you have to keep those two things in mind. Okay. So remember I said that you need to make sure you understand and remember your unit circle. Questions pertaining to this would be possibly more likely on the non-calculator than the calculator part of the test. Okay. All right, so let's do a couple practice problems using the unit circle. So either take out your unit circle, flip it to it in your notes, or just use it from your brain because you have it memorized, right? So up first, okay. All right, so up first, we have cosine inverse. So cosine inverse is telling us that we're only using quadrants 1 and quadrant 2. Does that make sense? Because that's where between 0 and 180, correct? Between 0 and pi is quadrant 1 and quadrant 2. So it's asking you in quadrant 1 or in quadrant 2, which would I be using? If I have a negative cosine, am I going to be in 1 or 2? I have to be in 2 because everything in quadrant 1 is positive. So we need to be in quadrant 2. So looking in quadrant 2, it's asking when does the cosine ratio equal negative square root of 2 over 2? And cosine represents our what? Cosine is your x. So when does x in quadrant 2 give you a negative square root of 2 over 2? In quadrant 2.
Square root of 2.
That's the answer. When do I get it?
Oh.
What angle gives me this value? That's in quadrant 1. We're in quadrant 2. 135. 135, which equals 3 pi over 4. I never heard you say 3 pi over 4. You just said it. Oh, you're trying, but you did it. Trying and different and saying you're different. Okay. All right. So let's try it again. Sine. Sine inverse is only analyzed in which two quadrants? First and fourth. So only look in first and fourth. Because I want a negative, it has to be in the fourth. So in the fourth quadrant, I'm looking for when does the sine ratio equals negative square root of 3 over 2, which means I'm looking at the y, correct? Sine is your y coordinate. So in quadrant 4, when do I get y? So Randy says 270.
I don't know.
You should fix it. Huh?
235.
I said take out your unit circle. It has to be more than 270. We have a 7.
Wait, I got this. Let me think.
6 pi over.
It's 5. That's the one.
It's the y. When is the y?
5 pi. For
Negative 2 square root of 2 over 2.
it's 200.
Negative
I need someone to be confident. Emiliano's the most confident that we're saying. All right, let's talk about quadrant 1. Okay, so in quadrant 1, remember I showed y'all the hand? Okay, quadrant 1, this is 0, this is 30, this is 45, this is 60, this is 90. Did I? I did.
I don't remember.
I feel like I did. Okay, here's your quadrant 1. In quadrant 1, if I'm looking for all this will tell me the cosine of every value in quadrant 1 from the unit circle. Does that make sense? So in quadrant 1, if I need to know the cosine of 30, I put down this finger that represents 30. The cosine of 30 would be the square root of 3 over 2. In quadrant 1, if I need to know the cosine of 45, I put down this finger, and it's going to be square root of 2 over 2. I put down this finger, and I get the cosine of 60, which is going to be square root of 1 over 2, which is just 1/2, right? 1 over 2, okay? If I know that this is 1/2, then it's opposite. It's y has to be the square root of 3 over 2, correct? So if I'm looking for when sine is square root of 3 over 2, that's going to be a 60-degree angle, okay? Or a pi over 3 angle. That's in quadrant 4. So like Emiliano said, in quadrant 4, that is 5 pi over 3. However, 5 pi over 3 is not in our range, is it? It's not. Our range is from negative pi over 2 to positive pi over 2, which is why you can use quadrant 1. All it's going to be is the negative, the opposite of this positive pi over 3. So instead of my answer being positive pi over 3, it's going to be negative pi over 3. So again, quadrant 1, you have 30, 45, and 60. This is pi over 3. This is pi over 4. This is pi over 6. You should know quadrant 1. In quadrant 1, you have your 1/2, which means that this is square root of 3 over 2. You have your square root of 2 over 2, comma square root of 2 over 2. And then you have, I didn't leave enough room, but square root of 3 over 2 and 1/2. It got weird. If you know and memorize quadrant 1, then everything else will be fine. If you do not remember quadrant 1, then everything else you may struggle a little bit. Okay, so in quadrant 1, I know that I get positive square root of 3 over 2 at 60, at pi over 3. So therefore, in quadrant 1, it's going to be the opposite of it. So in quadrant 4, this is at 0, remember that goes there. In quadrant 4, that would be this angle right here. This would be negative pi over 3. So my answer here is negative pi over 3 or negative 60 degrees. Does that make sense? Okay, why doesn't it make sense?
Why wouldn't people do 5 pi?
We can't, because our domain restriction for sine is from negative pi over 2 to positive pi over 2. And 5 pi over 2, 5 pi over 3 is outside of our domain restriction, right? Okay. All right, let's talk about tangent. Tangent is in what quadrants again?
It's sine over cos.
It's in quadrants 1 and 4. And it's going to be sine over cosine, which is our y over our x. Okay. We need a positive tangent. So which quadrant am I focused on? 1. So in quadrant 1, which ratio of y over x gives me square root of 3? I only have 2 options. I have this one, and I have this one. It's going to be the first one because you keep, change, flip. Square root of 3 over 2 divided by 1/2. We keep, we change, we flip. And it's just going to be square root of 3. So the answer is positive pi over 3. If you don't get what I mean, it's your y divided by your x. So square root of 3 over 2 divided by 1/2, which means I'm going to multiply by 2. And what happens to the 2's? So the answer is just square root of 3. That's what you're going to have to be able to remember from the unit circle and be able to utilize it on the non-calculator part of the test. Quadrant 1 is your best friend. If you know quadrant 1, you know everything else. Okay? Questions, comments, concerns?
But how did you figure out the 10?
How did we figure out 10?
Yeah.
We did y divided by x. Y over x, so square root of 3 over 2 divided by 1/2. We keep, change, and flip. Multiply by the reciprocal.
I thought that was the 7.
That was for tangent. That's how we confirmed it.
Sorry, if we do the 7.
Did we have to?
Oh, sorry. Huh? No. So I was just showing you. Yeah. Why it was. Randy said the first highlight, and I wanted to make sure you understand why it was the first highlight. All right. Our last thing.
Oh, wait.
So here we have an image, and it says the terminal ray intersects the unit circle point P, whose coordinates are x and y. The points Q, R, and S are results of the terminal ray, being reflected over the x-axis, the origin, and the y-axis, origin, and x-axis respectively. For each of the following expressions, determine which label point intersects the terminal ray of the given angles. Okay. So the first thing I'm going to do is it wants us to figure out which value can be cosine inverse of x. And we're only using each point once. Well, technically twice, I think. Yeah. We're using each point twice. Okay. So when we talked about, we can eliminate one point automatically. What quadrant did we not talk about when we said, talk about the inverses? Third. So are we going to be using point R at all? No, because quadrant 3 is not used when you're talking about inverse trigonometric functions. Okay. All right. So which one of these could be the inverse of x? X can be in what quadrants again? It can be in 1 and in 2, correct?
Yeah.
So it can be in 1 and 2, and I need a positive x. So which one is it going to be? It's going to be what? Which 1? So the 1 in quadrant 1, and what letters in quadrant 1?
P.
P. Remember, this is 1, 2, 3, 4. Yes? All right, let's do B. Sine inverse. Sine is in either quadrant 1 or quadrant 4. If I need a negative sign, which quadrant am I in? 4. So what letter is that? S. Are y'all with me? Next one. So quadrant 1 or 2, and I need a negative. So it has to be Q, letter Q. All right, tangent. So for tangent, it's either going to be in quadrant 1 or quadrant 4, and I need to be negative. So which quadrant? And therefore it is S. Yes. You just need to be able to identify which quadrant. That's step number 1. Yes. Well, I'm giving you time to work on your assignment.
Which one is
I'm
the-
looking at number 2.
Q.
No. Q1 or two?
Quadrant 1 and quadrant 2. Oh, out of here, it had to be in quadrant 2. As long as you don't take my pass home with you.